So, welcome to lesson number 5. We're on Refraction 2. We're now on the second part of this lesson. We're looking at lens problems, where we're going to take a more mathematical approach. The previous lesson, I suppose, we were drawing ray diagrams, and now we're going to solve a lot of these problems mathematically using a formula that you've already seen anyway when we did mirrors. It's going to be exactly the same formula. So, you've got your notes for this lesson. So I want you to scroll down to 5 part 2, lens problems. So let's have a look at this in more detail. So here I've got a convex lens or a converging lens. I have an object outside 2f. Well, where's the image going to end up? We're not going to draw the ray diagrams here. We've already done it, but you should know when the object is outside 2f, then the image is between f and 2f on the far side. So let me apply some mathematics to this now. I'm going to get a formula. You know that the distance of the object to the lens, that's called the object distance. And we call that object distance mu. The distance of the image to the lens, that's v. And the distance of the focus, capital F, to the lens, we call that the focal distance or the focal length, and we call that little f. They're the 3 letters we're going to be using, just like we did with mirrors, U, V, and F. And the formula that brings them all together is the lens or mirror formula. It's 1 over U plus 1 over V equals 1 over F. What else do I need to know? Well, you need to know a thing called magnification. So we always take the absolute value of the magnification. If the absolute value is bigger than 1, it's magnified. If it's less than 1, it's diminished. And if it's equal to 1, same size. So the formula for the magnification M is V over U. We could also look at the magnification in terms of the heights if we want. The magnification is the height of the image, HI, compared to the object. So if the image happens to be twice as big as the object, that means the magnification will be 2. If the image is 1/3 the size of the object, M will be 1/3. So there are your formulae. I'm not writing down all their meanings because we already know that. So let's just go back to our notes for a minute. You can see these formulae in your notes. So you've got your main formula here, and you have your magnification formula here. The formulae are to be found on page 60 of the table book. So make sure you color these in. When I go to my table book, there's my formula. We've already colored them in anyway for the lesson we did on mirrors. You can see it's the mirror and lens formula. It's the same thing. And the magnification formula is this formula here. They're the formulae that you're going to be using here. Now, what's really important when you do these problems are the signs. It's the one place where you can go wrong. And think about this. Real is positive. Now, what does real mean? Inverted images are real. And if we're talking about a lens, real images are on the other side, whereas mirrors, they were on the same side because mirrors bounce light back, whereas lenses allow light to pass through. Virtual is negative. Now, convex lenses have a positive focus, a real focus, whereas concave lenses have a negative value for the focal length because it's a virtual focus. So let's have a look at some problems. Anything else we need to look at before I go on? Little bit of STS there, real-life applications. Lenses are used in optical instruments like telescopes and microscopes and in the human eye. Okay, let's go to example number 1. In example number 1, an object is placed 15 centimeters in part A, 5 centimeters in part B from a convex lens. with a focal length of 10 centimeters. F will be plus 10 because it's a convex or converging lens. You have to find the image position, V, and the magnification, M. They also want you to mix this up with ray diagrams. They want you to draw a ray diagram of the situation, and they want the nature of the image. Well, let's go ahead and do the mathematical approach first. So here we have example number 1. So an object is placed part A 15 centimeters from the lens. Well, the object distance is called U. So U is equal to 15 centimeters. Look, leave the units in centimeters or millimeters, and the answer will be in centimeters or millimeters. No need to change them to meters, unless there's a particular situation that arises. But in general, just leave them in the units you get them, and the answer will be in those units. The focal length, it's a convex lens. And convex lens means converging. It means it's got a real focus where the rays of light actually pass through it. And therefore, F is equal to plus 10 centimeters. And they're asking me to find the image distance and the magnification M. They're the things they're asking me to find. Right, let me apply my formula. Write down my formula. 1 over U plus 1 over V is equal to 1 over F. 1 over 15 plus 1 over V is equal to 1 over 10. So you can use your calculator if you wish, but when they're nice and simple or straightforward, I prefer to do them manually. I get rid of the fractions by multiplying right across by what does 15, V, and 10 all divide into? They all divide into, say, 30V. So multiply each term by 30V. That'll get rid of the fractions for me. So 15 into 30V will give me 2V plus V into 30V. That will give me 30. That's equal to 10 into 30V will give me 3V. Bring my V's to the right-hand side, say. 3V minus 2V is V, and that's equal to 30. Therefore, my image distance is 30 centimeters. Now let me work out the magnification. My other main formula is M is equal to V divided by U. My value of V is 30. My value of U is 15. You get a magnification of 2. That means the image is twice as big as the object. Does that make sense to you? Well, the object distance is 15. The focal length is 10. 2F is 20. So that means I'm between F and 2F. So yes, it does all make sense to me. They're asking me to get the nature of the image. But the nature will come in 3 parts. First part is it real or is it virtual? Well, actually, the maths will tell me. You see that value of V? The sign is plus 30. That means it's a real image. And as I've said before, the first part is real, the last part is inverted. All real images are inverted. And is it magnified or diminished to the same size? Well, M is 2. The absolute value is bigger than 1. So therefore, it is magnified. Now, why don't you try this yourself? Nice bit of revision from part 1 of the lesson. Why don't you go now and draw the ray diagram and satisfy yourself that everything matches up. That the maths, when you draw the ray diagram, I put the numbers in on the grid. There's F at 10. There's 2F at 20. Show that the numbers match up with the ray ray diagram. The mathematical approach and the ray diagram amount to the same. So it's a nice bit of practice. So let me look at part B of this same problem. So part B, I've now moved the object to 5 centimeters. So U is 5 centimeters. I'm talking about the same lens, so F is still at 10 centimeters. You can see there, can't you, that the object is inside the focus. And what does that mean? You should always have some sense how the problem is going to turn out. That's image formation diagram number 5. When you put the object inside the focus, it's like a magnifying glass. You're going to get a virtual magnified image. So I have that in my head, and hopefully the maths will show me. And then you're going to check it later on by drawing the ray diagram to see if the ray diagram and the maths all match up. So they're asking me to find V, the image distance, and to find M, the magnification. So let me write down my lens formula. 1 over U plus 1 over V equals 1 over F. You know, always do that in the exam because they'll give you 3 marks for writing down the relevant formula. And you're just copying it out of your table book. That's great. Replace my numbers, my letters by numbers. 1 over 5 plus 1 over V equals 1 over 10. Let me solve that manually. So I want to multiply right across by some number. Each term by some number. That will get rid of all the fractions. 10V, 10. They all divide into 10V. The 10V looks good. 5 into 10V, 2V. Plus V to 10V is 10. And that's equal to V. Now bring my V's to the left. So I get 2V minus V is V. And I'm going to bring my number the other way. And I get minus 10. So V is actually 10 centimeters. What does the minus mean? It means it's virtual. It means it's on the same side of the lens as the object. So I already know the first part of the nature. It's virtual. And of course, if I know the first part, I also know the last part. It's upright. Let's work on the magnification. Write down the formula. M is V over U. V is minus 10. U is 5. I get a magnification of minus 2. Don't make the mistake of saying the minus means it's diminished. Take the absolute value of that number in your head, and you get the magnification is 2. And that means it's a magnified image. That's the middle part of the nature. So I have produced a magnified image, twice the size of the object. If they ask me for the height of the object, I can use my other formula, couldn't I? So, for example, if the height of the object was 5 centimeters, that means the height of the image is 10 centimeters. It's twice that. So, I want you also, in this question, to do the ray diagram. You've got the ray diagram here at the end. So do that ray diagram and show that the maths and the drawing match up exactly. So it's great practice. It means you've got a great facility with lenses and you know exactly how they work. So let's move on to example number 2. So example number 2, we're told that an object is placed 12 centimeters from a concave or diverging lens. Remember, F is negative here because we're talking about a virtual focus. The focal length is 8 centimeters, so I'm going to have to put F is equal to minus 8. They're asking me to find the position of the image, V, and its magnification, M. And also, what's the nature of the image? They're the 3 properties that we keep on talking about. So let's have a look at this particular question. So what's my information? U, the object distance, is 12 centimeters. U is always positive. It'll never be negative. F, focal length. That focal length is minus 8 centimeters. You have to put in the minus. So getting the signs right here is absolutely crucial. I'm looking for V, and I'm looking for the magnification. They're the two things that I'm looking for. So what do? Write down your formula for the lens. 3 marks just for doing that. Fill in the numbers. 1 over 12 plus 1 over v is equal to 1 over minus 8. I can throw the minus in front of the fraction. Minus 1 over 8. Then I want to get rid of all those fractions. I can use my calculator, but they're easy enough. I like to do them manually. The next question is going to involve a bit of algebra anyway, so you need to be able to know the manual technique for doing it. So what does 12v and 8 all divide into? 24v. So multiply each term by 24v. 12 and 24v is 2v plus 24 minus 3v. Bring my v's to the left-hand side, and I get 5v is equal to minus 24. Yeah, of course, I expect v to be negative, don't I? Because we're talking about diverging lenses, and the only kind of image you get there is a virtual image. So I get v is equal to minus 24 divided by 5. You can decimalize that if you want. So that's minus 4.8 centimeters. So that means it's 4.8 centimeters on the same side of the lens as the object. I also want to work out the magnification. So the magnification m, v divided by u. My value of v, let me leave it as a fraction, is minus 24 fifths. Divided by u, my value of u is 12. Do that in your head or your calculator, and I get an answer of minus 2 fifths. The minus just means it's virtual. In my head, take the absolute value of that, and the absolute value of that tells me the magnification is 2 fifths. That value is less than 1, so obviously it's diminished. Anyway, I know that all images in concave lenses are diminished. So what's the nature? 3 parts. Look at the sign for v, it's negative. That means it's virtual. And that means the last part is upright. And the middle part is the magnification, and it is diminished. So I have a virtual, diminished, upright image. So look, the most important thing is the sign convention. So F for concave, diverging lenses, F is negative. F for convex, converging lenses, F is positive. But keep that in mind when you do the problems. Right, let's move on to the next question. So here's my next question. So it says to me, how far must an object be placed from a convex or converging lens of focal length 15 centimeters? Immediately I know F is plus 15 because we're talking about convex. To produce in part A real image half the size of the object, and in part B, a virtual image 3 times the size of the object. This is probably the hardest kind of problem that you can get. But look, it's just a technique, so we'll have a look at the technique. So let's look at the problem in detail on the board. So, what have I got? Well, I know the focal length, F, is plus 15. In part A, they want a real image half the size of the object. I've got the magnification. The magnification M, because it's real, my magnification will be positive. And the magnification is a half. So that's the information I've got. They're asking me how far must an object be placed. What are they asking me to find? They're asking me to find u, the object distance. Well, let me start by using the magnification formula. M is equal to V over U. So, if you like, you can replace M by V over U. Put that equal to plus a half. Multiply cross by 2U or cross multiply, and I end up getting that 2V is equal to U. Put a box around that. 2V is equal to U. I don't have U, and I don't have V, but I do have the relationship between them. You can see that U is 2 times V. Now let's go to my other formula, which is 1 over U plus 1 over V equals 1 over F. Now, as I said, I don't have U or V, but I do have the relationship between them. I can replace U by 2V. So I can say 1 over U, which is 1 over 2V, plus 1 over V is equal to 1 over F, which is 1 over 15. And you know what I've done now? I'm just left with one unknown called V. So let's go to my normal tidying up procedure. Multiply cross by 30V. So what do I get? 2V into 30V goes 15 times. Plus V into 30V is 30. And 15 into 30V is 2V times. So I end up getting 45 is equal to 2V. They're actually asking me just to find U. So if 2V is 45, well, 2V is also equal to U. That means we can say that U is equal to 45 centimeters. So that means you'd have to place the object 45 centimeters from the mirror in order to get a real image half the size of the object. It kind of makes sense. You know, when you're outside 2F, which you will be, 2F is 30, I'm outside 2F. You know, that's the first ray diagram we did in the first part of this lesson. Now let's look at the other one. Where must I place the object in order to get a virtual image 3 times the size of the object? Well, we're talking about the same lens, so F is equal to 15 centimeters. The magnification is 3, but I've got to put in the minus because it's virtual. So therefore, M is equal to minus 3. Start off with the formula for M. Replace M by V over U. V over U is minus 3. Slide the U up to the minus 3, and I end up getting V is equal to minus 3 times U. Put a box around that. That gives me the relationship between V and U. Now let's go to my other formula. 1 over U plus 1 over V equals 1 over F. 1 over U. Well, just write down the 1 over U. 1 over V. Replace the V by the minus 3U. So it's 1 over minus 3U. Throw the minus in front. So it's minus 1 over 3U is equal to 1 over F, 1 over 15. So how do I solve that kind of problem? Well, I multiply right across by something that all those fractions divide into, and they all divide into 15U. So now, U into 15U goes 15 times, minus 3U into 15U goes 5 times, so it's minus 5 is equal to U. So I get U is equal to 10 centimeters. Does that make sense? Well, the focal length is 15 centimeters, so U means I've gone inside it, means I'll get a virtual image. So all that makes sense. It's great when you have an understanding of all the ray diagrams, and then when you do the maths, you know, the maths tallies with the ray diagrams as well. Well, let's have a look at one final example. It's slightly unusual example. It's actually very simple. You've got an object and a screen are placed 30 centimeters apart, as shown in the diagram. You've got a convex or converging lens between them. They're telling me that the image is twice the size of the object. That's formed on the screen. That means M is +2. Why do I know it's +2? Because only real images can be formed on a screen. You can't form virtual images on a screen. They're formed in your mind's eye. And you've got to calculate the distance of the lens from the object and from the screen. In other words, calculate U and V, and finally the focal length of the lens. That's the problem. So let's have a look at it in detail on the board. There's the setup there. The first thing you can see immediately, U is the object distance, the distance of the object to the lens, and V is the image distance, the distance of the image on the screen to the lens. And the object and the image on the screen are 30 centimeters apart. So immediately you can see that U plus V is equal to 30. So let me write down that simple relationship. U plus V is equal to 30. You're also told the magnification is 2. And as I said, you know it's +2 because it's formed on a screen. And only real images can be formed on a screen. M is V over U. So therefore V over U is equal to 2. That implies, slide the U up to the 2. You've got V is equal to 2U. So I have that relationship between V and U. And I've also got this relationship between U and V again. So I've got two very simple equations to solve. So replace V there by 2U. So therefore U plus 2U is equal to 30. 3U, 30. And therefore U is 10 centimeters. And therefore what's V? Well, V is twice U. So V will be 20 centimeters. You've worked out your values of U and V. Finally, I want you to work out the value of F. So now I'm going to write down my lens formula. As usual, fill in the numbers. 1 over U is 1 over 10, plus 1 over V is 1 over 20, and that's equal to 1 over F. So again, we use our trick to get rid of all those fractions. What do you multiply right across to get rid of them? Well, I'm going to multiply right across by 20F. So they all divided 20F. You know, it's simple enough to do without your calculator. And as I said, the previous example that we did was algebraic, so you couldn't have used your calculator. So you needed that technique for the algebraic one in the previous example. So 10 into 20F is 2F, plus F is equal to 20. So I've got 3F is 20, and therefore F is 20 over 3 centimeters, or about 6.7 centimeters, whatever way you want to write it down. Okay, that was slightly unusual, but it's easy. No problem. The hardest one was actually the previous example, number 3. That's the one they ask most often, so know that very well. Okay, so that's the end of the lesson, and it's now over to you to do your practice. You know, you've watched everything. I've explained every kind of question you can have. If you go down to your numerical problems towards the end of the notes, there's a nice selection of questions. I want you from part 2 of this lesson to do from 1 down to number 10. After that, we're on to the power of a lens, which is going to be the next part of the lesson.